Today, as the slide shows, we are going to introduce the model context protocol. I think I will mainly focus on why, what, and how, right? So I think this is a good way to understand a new concept that was just raised, I think, last November. So today I will first introduce the main concepts in MCP for you to establish the overall framework. And then Ishan will share a demo and to help you learn about how to initially set up AI agents and see how it's going to interact with the MCP. First question, why do we need MCP? Right now we see lots of LLM AI agents shows up, right? And what makes the AI agent powerful is their ability to utilize different tools, right? The tools can be accessing a database, do a web search, or call a third-party API calls. Before the MCP is introduced, everyone is doing their own tools for LLM. So I put some example here. It's like this is how the LLM, how the LLM interacts with tools without MCP. Right, so the user asks a LLM, like for example, a simple question like, "What is the time in London right now?" The LLM say, "Oh, I need to write a program, right, to get back the time given a location." And then when it writes a program, there are many ways to write a program, right? It can call existing website API, say some website have some simple API to return the time given location, or you can also access the system, right? Just your laptop, your operating system to get you the time. So there are many different ways to implement the tools. What makes it even more complicated is user for the LLM, different LLM based on the model you choose, based on the tool you use, you may have different get current time functions, right? So you have get current time A functions, which can just return you the time there, and then get current time B function, which returns like a kind of a JSON format of the key value pairs, like time is keys, and then the value is like 3 p.m., right? And then the current time C function will returns another different JSON format to say, oh, I will also include a location in my response to make it like more holistic response, right? So you can see there are so many possibilities to implement the functions, and also each function's the response format can be different, which will cause the LLM is like, well, the LLM needs to pass lots of like different formats, and it's really a growing pain for LLM to figure out what tools to use, what tools to create, and understand various formats from the response. So this is where the MCP is originated, is to solve the growing pain of how can we standardize the tools, including the response format, so that the LLM can understand the format and can basically reuse whatever tools already available without starting from scratch. So one sentence to summarize what is MCP and also why we need MCP is the MCP is kind of like a universal USB standard for LLM tools. Right? If you think about like a USB right now, like every device has its own, the USB can be inserted into a laptop, a screen, a monitor, or printer, right? So every device can connect with a USB because the USB standard is there, and every device can design its own connector to connect, basically just integrate the USB standard into their own connector. Same with the MCP, right? This is the standards for all the LLM tools, so that the LLM know how to invoke the tool and also understand the response from the tools. The benefits of the MCP includes first, as you see, right, the standardizations of the LLM tools. So it defines how the LLM can call a server to invoke that tool, and also defines the response format, like what is what is the output of LLM tool after executing that tool. And then the second, I think, is the flexibility and scalability, because once the standard is there, you kind of enable an ecosystem, right? Like you enable an ecosystem and community for everyone to contribute. So the server of tools is no longer limited to you, to just you or to the team that who are trying to develop the tools, but enable everyone can, contribute to developing their own tools, and also enable all the third-party vendors to basically contribute to the tool development so that any AI agent can use. The third benefits is also it enhance the capabilities of AI agents overall. One side is clear, like it introduced a whole lot of tools, right, for the AI agent to use. On the second perspective, I think it also simplifies the training of the LLM itself, right? For the LLM to better understand what tools are available, how to use the tools, and so that format is kind of much clearer right now. And then we can use that as the inputs even to train the LM to better understand the tool use. I also pull the timeline of the MCP. I see it as the power of scale. It was originated November last year. Well, Anthropic introduced and also open source the MCP as a standard of connecting the AI agents or systems to the data systems. And then in January, you see the like Z, client, and cursor. So these are all coding agent that they add the MCP support. And then in February, we also like the cloud code also has the, I think at that time is still local MCP support. And there are also like 1,000 open source connectors emerge. So that's the power of scale. Like once you define the standards, everyone can just stick with the standard and contribute to this MCP server. And then in March, Cloudflare and Sentry release guys for deploying a production-ready remote MCP server. And then people start developing the remote MCP server so that any AI agents can access and leverage the tools on those servers. And also OpenAI officially adopts MCP. Then April, like a Visual Code Studio and also GitHub, and also later the Copilot also adopts the MCP integration. And in May, AWS also introduces the serverless MCP server to host the MCP server. And in June, Cloud Code also enables the remote MCP support. Well, in the Cloud Code itself, you can config a URL that for the remote MCP servers. Then it's very easy to interact with the external remote server that exists over the internet. And then let's move on to the what part. So first, I think I can introduce the overall architecture for the MCP. It mainly has three parts. So one is the client part, or also called like AI host or the MCP client part. And then there's the server part, and then there's the data sources. Right. So the AI host or the client is kind of more customer facing interface, right? So you can choose to use any LLM model, no matter it's like Cloud, ChatGPT, or like an AI agent, like the Cursor agent, or any open source model. So you can choose your own LLM model as your AI host. So this step is to understand the user intention. So that is kind of like a chatbot, right? So it's like a natural language interface for the users. And then it will, so there will be a MCP client. So this is mainly to set up connection to the MCP server, right? It can send a request to the server, for example, to pull, say, give me a file, this PDF. Say like a simple command like that, right? And then the MCP server provides adapters to various kinds of resources. It can be file system, it can be databases, or like a third-party APIs. And then it will execute it, like because you build all kinds of connectors on the server to these data sources. And then you execute that command or like a SQL, right? And then it will return that data. And then the server will also pass that data to the client and thus the LM. And then the LM will transform that response into a response to the user. So this is usually like the three major components in the MCP. So basically, yeah, so the MCP client or the AI host translates the request into a standard protocol format to communicate with the MCP servers. And then these MCP servers then will interact with the external data sources. So this is MCP use in a real life example. Let's say we have some smart home system, right? Who can take voice controls to adjust the temperature of your AC, right? The user can give a language command to say make it a bit warmer downstairs, right? And then the client or the LM the client use will pass this command and say, oh, I want to make it warmer, and also the location is downstairs. And then it will communicate to the MCP server to say, oh, what tools are available there? And then our MCP server will respond with a list of tools available on the server, including tools, say, increase temperature, right? And then the client will send a request to the server to say, oh, increase the temperature plus 2.5 downstairs, right? And then the MCP server will also interact with the smart home devices. So this will be that connector that it has built to connect with the smart home system. Post that request to the smart home system to increase the temperature. And then it will respond to the server with the result. And then the MC server will again send the response to the client, and the client will send it back to the user, right? So you see the major interaction over here, the client is trying to pass the user command, making the right call to the MCP server to figure out what tools available and which tool to use. And then the MCP server will execute according to which tool is chosen. It will execute the request to the either a device or database or some resources, right? And then after execution, it will send back the results to the client, including the LM AI agent, and then that agent will respond to the user. So this is kind of like a simple example of how the MCP is used in a simple real life example. So if you and I think one key part over here, you see there's lots of communications, right? Among the user to client, and there will be lots of communications between the client and server. Then what is the protocols that the MCP use to enable this communication over the network? So at its core, MCP uses a JSON format, a JSON PRC 2.0 format as a message format for all the communication between clients and servers over the distributed networks. Like no matter it's a local one or like a remote one, right? And then this JSON format is a lightweight remote procedure call encoded in JSON format. And then in response, regards of like how you communicate this JSON or send this JSON over the network, there are two ways, mechanism currently used. Maybe there are more showing up, but currently it's mainly a HTTP calls. Like it can be a streamable HTTP calls, like you can just send the HTTP request in Python in any language, right? You can just request, make the HTTP request to the server. Or you can also use the server send events. Server send events is also extension to HTTP that the normal HTTP is usually just like request and receive type of communication, while the SSE, the server can initiate the response by itself, right? It doesn't require a request from the beginning. So it's a more server-initiated events. So these are the kind of how the JSON format are sent across networks. So if you look into the JSON format, right, so you can specify, okay, what is the version of the JSON format? What is this method you want to call, and what is the input parameters for the method? Right, so the tool call is like a weather. So the weather is a tool, and then the argument for the weather is San Francisco, right? And then from the server to the client, it will respond again in the JSON format. And with the result is again a JSON is like the temperature is this and the conditions is this. And also it enables the server to send the arrows, right? You can also implement your um, arrow handling mechanisms on the server side to make it more robust. Like for example, if the location doesn't exist, right, you can just say it's an invalid location input. So this is usually the interaction life cycle of the MCP. There are mainly like four key stages. The first stage is, so this is the client and then this is the server. It will do the initial connection with it, right? To make sure that the connection are secure. And then it will respond to the client connection request, and then the connection is initialized. And then there will be a tool discovery phase where it will send a HTTP request to the server to figure out tools list, right? So this is a kind of a request to the server to get the full available tools from the server so that the LM can grab those knowledge in the prompts. And then based on the user request, the client will start sending the tools call. Like the LM will reason about the user request and then figure out which tool to use. And then it can just do the tools call to the server. And then the server will also respond. Maybe it will report the progress, or it will also respond with what is the final answer, right? And then say after all the execution is complete, there will be also if you want to disconnect, and then you can just send the shutdown, and then you basically disconnect it from the server. Yeah, so these are the major interaction lifecycle between the client and the server. I think the key part that I haven't touched, this is the key part that I want to understand is how LLM is able to use the tools available on MCP, right? So, well, this is the best I can guess because I actually cannot find a full prompt of an AI agent that are like the detailed prompt, how it's interacting with the server to use the tools. But this is my guesses and also based on the coding agent that I see, right? So usually the prompts for the LLM, no matter what LLM you use, it usually starts with the system prompts, right? Like you define the role of the LLM. For example, you can define like you are a helpful AI assistant, and then you are able to leverage these external tools. And then your primary goal is to interpret the user request, identify the tools, and provide the parameters to invoke these tools, right? So basically you kind of introduce what is the role of the LLM in the beginning, and then you can pass in the user request over here. And then you also include all the list of available tools from the server. Basically, after sending the request, the tool list request to the server, you kind of know what are the available tools there, right? With the description and parameters and return types. And then you can also like give the LM some knowledge about what is the example of how to use these tools. And then you can give it the step-by-step instructions, right? Like analyze the request first, then select the relevant tool, identify the parameters from the user request. And also if the tool is selected, then output the JSON format, which the client can send to the remote server to execute that tool. So the output of the LM can be just the JSON format to be sent to the server. Okay, let's move on to the MCP server, which really makes how it kind of empower the AI agent and make it more powerful. So there are four types of I would say resources or tools that the server has access. One is the resources, right? It kind of integrates all the files and data that the server can provide to the AI as the context, like including like a SQL database, right? Like all types of the data you have. And then the tools is more like there are many different ways, right? Like it can be a command line execution. It can be write a SQL to modify the data. It can be your web search API or any third-party API, including the payment API, if you want to grant the AI agent the permission to make payment for you, right? So it can kind of has lots of I would say, unlimited possibilities with the tools. And also, it can be a prompt, even on MCP server. So these are more reusable prompt template. For example, how to analyze the codes, how to debug the codes. Well, people have optimized the prompts and make it ready for the AI agent to reuse to build the AI workflows. There is also a sampling on server side. This is a more advanced feature so that the servers can also the request the client, right? Previously, I mainly talk about like the client can request something from the server, while in the sampling function, the server is going to request something from the client. This will enable more advanced interactions between the client and the server. So let's look at the resources first, right? So the resources can be many different types, like source codes, configuration file, logs, plain text, or JSON. And also it supports binary resources like images, PDFs, or videos. Since it's a streamable HTTP call, so it also enable the sending videos, I think, streaming videos from the call. So it supports like many different types of data that the server can send to the client. So usually the format of the resources start with the protocol and then the host and the path to indicate where the resources is located and how to access it, right? So it can be a file system, it can be a Postgres a SQL database, or even a local screen. Like this is a local host. Like you can pass your full screen displays to the AI agent as well. And then each resource may include the URI indicating the location, the name of it, the description, the media type, and also the size of the files. So this is a resource format. And then on the prompts that's stored on the server, so it can be like the client just asks the server like what are the available prompts there, so it requests a prompts list, and then the server will respond to say, oh, I have an analyze code, and then the client say, okay, I want to get the prompts get this analyze code prompts, and then it will respond with the full prompts, right? The server will respond with the full prompts. Like this is the kind of the optimized prompts already, right? Like for how to analyze the Python code for improvements. And in terms of tools, I would say there's boundless possibilities with the third-party vendors. Right now, there's lots of vendors are already implementing these connectors for their own services. For example, this is to connect to Jira, Confluence, to manage the issues access. Cloudflare, right, to manage the workers deployments, and also this service for the AI agent. So they basically they develop these tools on the server for the manager to for the AI agent to manage the customer conversations, support tickets, etc. And also PayPal and Plate also implement secure, hopefully, secure tool on the server for the AI agent to enable the payment directly, right? So that is kind of the tools that the AI agent can use to directly fulfill the payment on behalf of the customers there. And also you see the InVideo. So InVideo, I think, is also a company that they are good at transform the text into a full-length video kind of using a diffusion type of model, right? So this is kind of also related to the computer vision, the question asked in the chat that yes, you can develop your kind of the tools to transform the prompts into video or to analyze the video, right? And it can be one of the tools that exists on the server for that. Yeah. So I would say any service companies is going to develop their own connectors and enable them on the MCP server so that the AI agent can use their services in a more flexible way. Yeah, so this is the tool format, right? So you have the name of the tool, the distributions, no descriptions, and then what is the input variables for the tools? And also these are all the tool probabilities, like whether like the title, whether it is a read only, whether it is destructive, and also if you run it repeatedly, does it has any effect? So this is more like some attributes about hints of the tool behavior. So this is how you define the tool on the MCP server. So this is just some examples of the tool definition, like a simple tool definition for the local system operation where you execute a shell command. Well, if you run a shell command, you usually have a string for the command, right? And then you have your arguments for the command, which is the array of strings. There can be a API definitions on like a GitHub create issues that you can automatically create the GitHub issues there, right? Including title, body, and the labels that you want to tag to the GitHub issues. Yeah, so this is a tool. So you see so this is what is actually stored. I would say like the information that the MCP server has. And then it will also make that connection, right? So if this GitHub create issue request is sent from the client to the server, it's going to actually execute it on the server side or on the third party vendor side. And then the last function the server has is the sampling, right? The server can also request from the client. So basically, it allows the servers to request the LLM completion through the client to enable more agentic behaviors. Also, it can ask approval from the users, right? Like to enable some human in the loop design. Because if you have used some coding agent, sometimes it's going to ask you to approve it, right? Like, for example, it's going to edit some files. If you do not want it to automatically save the file, it will ask approval from you after finish editing the coding files. So that this ensures that the user maintains some controls on what the LM generates. Right? So this is a sampling method that sent from the server to the client. And then this is like to create message the user. And then it basically say this tool wants to also understand what files are or in the current directory there. And then this is sent to the AI agent, and then the client is going to complete this request and then send the response back to the server. So yes, it can be both ways. Okay. Yeah. So this is what I want to introduce. So one sentence to summarize all is MCP is the USB standard for all the LLM tools. And also it enables the AI agent, the capability, like expanding the capabilities of the AI agents more in a more flexible and scalable way. And I do see it's still at the early phases. There will be more, I think, development around the security, right? Because if you are going to access the payments, the GitHub, all your personal accounts, there will be like you need to make sure that those executions are secured and not leaking any information. Well, it's just born like last November. I do see there will be more developments happening in this space to make it a secure and also more well, it's kind of balanced two sides, both secure and also easier to use to make it more convenient for the AI agent to execute the user request.
Awesome. All right. So essentially, MCP is just a protocol. It's a specification, and you can definitely read more about it in their documentation. But how do you actually implement MCP? So the easiest way to do that is using the fast MCP implementation. It's a Pythonic way to build MCP servers to expose your tools, but also you can build MCP clients so that you can read from those MCP servers and interact, have your LLM interact with those tools. So as you can see here, the fast MCP implementation makes it very easy for us to define an MCP server. So right here, we use fast MCP implementation, provide a name, then we expose a tool, essentially the add tool. And you can see here we provide a description. This description is actually used by the LLM to identify that, okay, to add two numbers, I need to use this specific tool right here. And yeah, so essentially all you do is run this MCP server. You can run this locally on your local host. You can run it on stdio, or you can deploy it on containers, let's say on a Fargate instance or Amazon SageMaker and so on and so forth. Right. So just wanted to give you a quick introduction to FastMCP because during the demo we would be using that. Right. So another technology that we would be using in the demo is Strands Agent. So Strands Agent provide a model-driven approach to building AI agents in a very few lines of codes. Right. So as you can see right here, all you have to do is pip install Strands Agents. And then you can start using agents as such by creating an agent instance, providing tools, and then asking question, what is the square root of 1764? And the agent here will use the calculator tool to provide to do the calculations and provide you a response. So Strands agents actually are powered by multiple model providers. So you can have, as you can see on the left panel right here, you can have models from Amazon Bedrock, Anthropic models, Light LLM, Llama, Olama, OpenAI, and so on and so forth. So in the demo here, we will be using models provided by Amazon Bedrock, specifically Claude 3.7 Sonnet. So and I will show you how you can do that integration with Strands in a quick intro. Awesome. So this is hopefully a lot of people on this call have already developed agents, but if you have not, this would be your first agent. So it's really exciting. So all you have to do is pip install Strands agent and Strands agent tools. So this is the first agent that you would be creating. So the first step here is creating an instance from Strands, providing a system prompt. System prompt here is provided by you as a developer. You define what is the scope of the agent, what are the underlying tools that it can use, and so on and so forth. So here you can see there are no tools, so we just provide a system prompt. You're a helpful assistant that provides concise responses. Now here you can invoke the agent with the user query. User query in this case is, hello, tell me a joke. Let's run the cell and see the response. So the response from the underlying LLM, which is Claude 3.7 Sonnet, is why don't scientists trust atoms? Because they make up everything. Well, we asked it to create a joke. Not a good one, but it did create a joke. Let's bump it up a little. Let's actually define some tools, right? So we with Strands, you also have a Strands tool library, as you can see right here, which provide a lot of pre-built tools like calculator. If you want to use RAG, you can use an underlying tool exposed by Strands tools. The easiest one is calculator. That's what we would be using. And in a real world scenario, you will actually be creating your own tools. And essentially, that's how you would do it. Is let's keep this very simple. We do a weather API which gets the current weather, right? Here you can see this is a dummy implementation. I'm just going to return sunny every time. But here you can imagine you can have your own code which executes the API, gets the current weather. Again, you create the agent instance. In this scenario, you actually provide the tools. So the tool provided by strands. This is inbuilt tools which the developer team maintains, and your own tool, which is doing some sort of processing. Again, now if we do what is the weather today, this agent should be able to first invoke the tool and then get a response. The weather today is sunny because it responded with sunny. Awesome. So let's actually see why we need MCP here. So, for example, I am creating tools that, for example, a web search tool, as you can see right here. So for this, I'm going to use DuckDuckGo to do web search. And this web search tool, I have a string here which describes the web search tool, which is used by the underlying model to understand how to use this tool. So search the web to get updated information. I describe some arguments and I provide, hey, these are the list of dictionaries with search results. And this is a tool that I create, and my underlying agent can use this tool. So let's quickly see how that works. Oh, I do need to install, and now we should be good to go. So if we do suggest a recipe with chicken and broccoli, first it's going to do web search, and then based on the web search, it should be able to provide a response. Right. So I created my own tool. But as you can imagine, you as a developer, when you're creating your own agents, you would be developing your own tools, and those tools will take different arguments and provide different responses in different formats altogether. And MCP is trying to standardize this agent to tool communication. Right. So how is it actually doing this? So let's see this MCP server GitHub repository. If you go to this specific repository, and I'm going to provide the link in the chat here, this repository actually exposes a lot of servers that you can use. For example, you can use Brave Search, or you can use the GitHub MCP server, or GitLab MCP server, Google Drive, Redis, and so on and so forth. They have a wide variety of MCP servers that you can use. So from a developer experience, all we have to do is get this MCP server that is being deployed in this GitHub repository. It is standardized, and we can put any technology. For me, I'm using strands. You can use LangGraph or Amazon Bedrock agents and so on and so forth. But this underlying agent, this GitLab agent, would be standardized, and the communication between our agent and the MCP server would be standardized too. So this is a big repository of MCP servers. I would definitely recommend checking them out. There are a bunch of MCP servers that AWS as well exposes. So for example, if you have AWS documentation MCP server, in the demo, we are going to be using this server. Awesome. So yeah, we built our first agent. Now actually go in and use model context protocol as tools with strands agents. All right, so let's install the requirements here. And don't worry, I will be sharing this code, all of these code in the chat once I'm done with the demo. So you can definitely go in and see and run the code yourself. All right, so let's import some packages, some dependencies. Yeah, as it was mentioned earlier, there are various protocols that you can use. The stdio is for local development, streamable HTTP, and SSE is more for when you want to deploy your MCP servers on a container somewhere, and you want different clients to use that MCP server. All right, so how do we integrate this with the strands? So strands actually exposes its own MCP client so that we don't have to write it. So the strands team, they have developed the client. They have written all the required code to establish a connection with the MCP server, list the tools, and invoke those tools. So let's see how that happens. So first, we use their MCP client that they have exposed, and then we provide some parameters. So as I mentioned, we will be using AWS documentation MCP server. And if you go to that MCP server right here, you will be able to see how to actually interact with the server. So the MCP server actually tells you, hey, to interact with the server, use this command with these arguments and potentially these environment variables, right? So I'm going to use exactly that from that MCP server's documentation, and I'm going to create my client. Now, the first step, as we saw in that entire process, was initialization. Essentially, you initialize a connection with the MCP server. So this with clause right here that you can see with STT MCP client initializes that connection with the MCP server. Then you do list tools to get all the available tools that this MCP server has. Then you pass these tools to your agent. And then you can ask questions like, what is Amazon Bedrock pricing model? Be concise. Um, so this particular MCP server actually exposes three tools. And these are search documentation, read documentation, and recommendations. So these three tools will be provided to our agent, and then agent will decide, hey, based on the description of search documentation, I actually need to search the documentation, AWS documentation, to find the pricing and provide a response. So let's see how that works out. Awesome. So first, it's going to initialize that connection. Then it's going to list the tools. It's done that in the background. So it's going to search documentation. So it searched the documentation. It got some response back. Based on that, it's going to start reading the documentation, and then it would provide the final response. Now, this has been standardized. This is what MCP is trying to do. Strands here is just one client that we are using. Let's suppose you're using Cursor or Visual Studio Code. All of those would use the same protocol. They're going to initialize the connection, list the tools, and then use those tools in some way. All right, so this was essentially us running STDIO connection to the MCP server. And I saw a question here. How would you use streamable HTTP? Does that work on localhost? Yes, it does. Let's see a quick example. So first, let's create an MCP server, a very basic MCP server. So we have a calculator tool that we expose. We provide a description. A calculator tool which performs calculations, x, y, and it returns x plus y. And we expose other tools as well. And when we run this particular MCP server, we actually this time specify that we want to run streamable HTTP. So let's run both of these cells. And then we start a local host, which, as you can see, this MCP server right now is running on our local host port 8000. And now, similar to what we saw before, we can actually start establishing that connection. So we define a streamable HTTP client, which is then exposed by strands. You don't have to maintain it. You use that to create a connection, and then the with clause for initializing, listing tools, providing those tools, and providing a final response. So let's see. So as you can see, we first did a post request that initialized the connection, the list tools, and as you can see, all of those things are happening. Everything that we saw in the diagram, everything is happening in the background, all the post and get requests. And then we find the agent decides to use the calculator tool and provide the final response. All right. So yeah, essentially, what all can you do? I know we're almost on time, but this way you can expose multiple MCP servers to your underlying agent. So let's suppose we used AWS documentation MCP server. We can also expose other MCP servers with more tools. And the great part about it is we can all look back to this particular repository, which is the Model Context Protocol servers repository, and we can just pick, hey, I want to use the GitHub server because I want my agent to review PRs, accept PRs, and so on and so forth. Maybe I want to use Apache Doris MCP server. So for you, for me, that entire experience, the development experience has been standardized with MCP.